Hello, and welcome to this new session on installing Kubernetes on Raspberry Pi. So the point of this session is to stand up a Raspberry Pi onto our network and install Kubernetes that will allow us to have some playground type environment so we can play and try out Kubernetes on a local system. So in preparation for this session, what I've done is I've created a new file here called session 5, let's discuss Kubernetes setup on Raspberry Pi. And I've marked it as an intermediate setup because some of the actual commands here will be a bit more intermediate. But even if you're a beginner, I would strongly encourage you to actually have a look and go through the file itself, point by point. It's an absolutely fantastic way to learn from others. When you need to move into the architecture world, you're constantly learning, and this is another example here. So even if you don't understand exactly everything that's happening here, Google or try to find out from somebody else, what the actual point of that actual step is. But in preparation for this course, what I've done is I've already set up my Raspberry Pi. So I've gone ahead and I've put notes in here, on good information about setting up your Raspberry Pi. I obviously did this. I chose my operating storage, which was Ubuntu. I chose my storage, which was my SD card, and I chose to write it. Okay, and I put another couple of links here about how to set up your Raspberry Pi on your network, and installing the operating system. And follow through these types of steps. The one thing I do want to mention here is, there's an advanced menu here, which is the gear icon. I would definitely do this. So this is something that I did, and I marked into the notes as well. Using the gear icon here, I would definitely do that. Make sure that you can set your host name and you enable SSH here, so that you can SSH into your Raspberry Pi. So those types of little steps I did, and I marked into the notes here. So I'm not going to redo all of these steps because the video would just be far too long. I've also put some steps of how to actually add user groups and users, and limit down access to your Pi, which is good practice. But really for today, we're going to start on the installation of the actual Raspberry Pi from here. So I've also kind of upgraded the system because for letting the video move forward, you can easily run through these steps and make sure that you complete all of these steps. But as you can sort of see, I actually have my Pi up here, and according to the notes, I've also called it master 2. So this is my username of Pi, and this is my host name of master 2. And this Pi will be taken straight back down off the network once this little tutorial is done. But to install our Kubernetes onto a Raspberry Pi, the first thing I need to do is just do an apt-get install here. So I'm going to run that, and I'm going to put in my password. That's going ahead. I'm going to take my second command. And later on in the sessions, we look at how we could actually automate, these type of activities, maybe using scripting first thing, or using something like Terraform. But just for today, the point is just to actually show the actual steps. So you can see here, we're going to redo an update here. So this is exactly what I would have just done a few moments ago, just to make sure that we get all of the latest packages down. While that's running, we're going to look at this next for kubeadmin. So I'm going to take this one here. So I've kind of left some notes here of how you could actually have the latest or a specific version. So this is the latest version. It'll be pulled down, and this one here is to install a specific version of kubeadmin. And if you go to the Kubernetes, you go to documentation here, you search for kubeadmin, you can see Using kubeadmin, you can create a minimum viable Kubernetes cluster that conforms to best practices. So that's exactly the role of kubeadmin. But really, in the next sessions, we'll get into what kubeadmin is, because certainly if you do the exams for the Kubernetes, you'll have to understand what kubeadmin is. And we know now that it's an administrative tool, but it gets into a lot more serious stuff in the later sessions. So let's say we've just done our app update, so which is good. So now I'm going to sort of say I'm going to install my kubeadmin, which I'm going to do here. And we're going to give it a minute. And do I want to install all of these packages? Yes, I do. And while that's happening here, so it's you can see it's going out to cloud.google.com, pulling down packages. But while that's happening here, I'm just going to go down a little bit, and I'm going to just explain a little bit about this section here. So I'm just going to say here, because I just want to kind of add some notes as we kind of go through these. So for the container runtime, we're going to use container D. Okay, so container D, let's just put it simply. Let's just search what container D is. Container D. So it says here, container D. Container D is available as a daemon for Linux and Windows and manages complete container lifecycle of the host system. This here is quite a complicated architectural diagram, but basically you can just think that container D will do the networking, will perform the networking between all of our actual pods. So we said in the last session that, let's find out what a pod was again. So the pod is the smallest unit available within Kubernetes. So it says pods are the smallest deployable units of computing that you can create and manage in Kubernetes. So you can see how, depending on this documentation, is critically important to understand, each of these concepts within Kubernetes. But in the exam itself, so you have access to all of this. You have access to this. You do not have to learn all of this for the exam. So I'm going to just put that link here. Here, some more information here. Container D, but basically it's the networking between all of our pods. So now that that is probably done, we're going to take our next command here, which it is done, and we're going to paste that. Okay, and this this is the kind of networking side. You don't have to worry too much about this if you just get the actual just get the commands run and updated and installed. And you can sort of see here we're going to install, CA certificates and curl and some packages that will be useful to the Kubernetes framework. And, yes, we want to install that too. And we're going to take our next command. And you can see why. I mean, if you were to do this on 100 machines, for example, definitely that, some type of automation would be really good. But I just have one new Raspberry Pi to install right now, so it's not, too bad I'm consuming, but you certainly wouldn't want to be doing this for 100 machines. So something like Ansible or Terraform would certainly help setting up these types of machines. So here we're going to install our container D that we just spoke about a minute ago. So I'm just going to do a little update again. And this just, this is always just ensuring that, we actually have the latest packages. So here's going to install our container D. And here it says we're going to configure our container D, which is going to be here. So when this is ready, we're going to wait for that. And it is ready. Let's see this, and we're going to restart here. I'm going to restart. check the status of this. You could do something like sudo system ctl status container B. So now we just need to add a new line into this file, so that we configure the kubelet agent to use container D. So let's just kind of do that. Let's just take this file, take this line, and let's sort of see where do we need to put it. Under the environment settings, it says, so I'm going to go down here. This is the environment settings, so I'm just going to put a new line, and I'm just going to, save this file. If you don't know these Vim commands, I'll put a link into understanding and playing with Vim commands. So certainly for the Kubernetes types of exams, but any type of configuration within Linux, you have various options to save and to edit files. So I prefer VI, but there is Nano as well. So there's kind of various options available, but right now I prefer VI, and VI is what I'm using. So let's kind of restart these. Again, we're kind of enabling the kubelet service, and we're restarting it here. And all of these components, we'll deep dive into. All of these components we'll actually deep dive into as part of our coming sessions. But just for today, we're not going to explain too much about Kubernetes, in the sense where we just want to show how we can actually get a running cluster on Kubernetes on a Raspberry Pi. So the next section here says, this is for master node only. Okay, so we are technically on a master right now. I do not have any second nodes. So really, I'm just going to run these commands here. Go, and I'm going to run this when the first one finishes. So you can see it's pulling down Kube API server, and it'll pull down. There's multiple components within inside of Kubernetes that we'll explore. But really, it's just basically going to pull down, controller, manager, and API server, and everything that allows Kubernetes to work together. Including here like the scheduler. That's just a component to schedule onto specific nodes, but there's various aspects there. And I'm just going to retake this. We're just going to wait for this for a minute or two. When that's done, we should be able to run one of our last components. Yeah, and we can just run this here. Okay, and what this is doing here, so let me kind of just come out of here. What this is actually doing here is it's basically saying, use the container D as the networking that we've configured previously. But what I want to do here is say kube-admin init. So initialize a new Kubernetes cluster using the container D that we specified and that we enabled up here. So that's all I'm basically doing right now. So this is why the kube-admin version is so easy, because it will go ahead and you can check all of the actual output here, but it will go ahead and it'll configure all of these application SSL certs. And that is one of the biggest parts. If you actually had to do this manually, that's one of the biggest parts that you would actually have to do yourself. And here, it also creates like your kube configs, and it sets up your control plane. Because as we sort of said before, your control plane is the master node that essentially controls most of the activities in your Kubernetes cluster. But it sets some tokens here, and basically sort of says here your Kubernetes control plane has initialized successfully. To start using your cluster, you need to run the following as a regular user. Okay. Now, I'm just going to, I have the same commands in here. So I'm just going to put those in here. I mean, there is some practices here that you would not do. I mean, you would not have a Pi user with a password of Raspberry, right? But you get the idea for today. It's not a security course. It's just to kind of show you that you actually can install a Pi with Kubernetes clusters. Now, one thing here I want to just kind of point out quickly is if I did have other Pis and I had them into a cluster, and I had them, linked up, what I could do here is actually do kube join on those worker nodes. They're called worker nodes. So the master is the master that will have most of the bigger components that are needed and required for the Kubernetes cluster. But you can have an actual worker nodes, and the worker nodes will be the place on the storage location where most of the actual activities in the Kubernetes cluster would actually take place, like running of pods or running of deployments or running of services and those type of things. And the master is the one that's basically saying, hey, I know in my worker node that this worker node A does not have a lot of resources right now, so I'm going to assign it some piece of work, and that is the role of the master node. But for today, I just have a master. So in a Kubernetes cluster, you can actually just have a master, but you can also have a master plus worker nodes. But if you wanted to join one of those worker nodes up, all you would simply do is you would have done most of the steps that we kind of did before, except for the kubeadmin. And then you would just run this type of command here that basically says, here's the token, here's the cert, and basically just join that worker node over into the master cluster. Okay, so that's what we would have done if we had have actually had more worker nodes. But right, for today, we're just going to have one master, because the point is just to show. Now, you can see here, we sort of said before that we have like all namespaces, okay? So we have all namespaces command here that we can pass in, and we can see, here's the components of the Kubernetes master. So these are actually pods, because believe it or not, we can create user-defined pods, but Kubernetes actually creates its own pods in this namespace of kube system. So that's the namespace that Kubernetes assigns as its own storage location to say, anything in there for me is mine. Then I could kind of create my own pods in like a namespace, my testing namespace or something like that, separated away from these. But as you can sort of see, most of these are actually running. Just two pending here, but they'll take a few minutes and they will come up. And for the worker nodes, I'm going to skip it for the moment, because we actually don't have any. We don't have any worker nodes right now, but I'm going to go into setting up the networking. So let's sort of see what we do actually have. So right now we have a kubectl get nodes, and you can see here there's a master 2 and the status is not ready, and it's got the role of control plane. And this is something that we saw in Kind as well, and Minikube as well. And it's got this version, okay? And like we were saying, you can specify a specific version. So if you want to study for a specific version or understand a specific version in your kubeadmin, you can specify a specific version for that. But right now, I just sort of said, install me the latest of the latest. And this is what it basically installed for me. But you can see here, my status is not ready. And my status is not ready because I haven't installed any of the actual networking side, okay? So if I kind of come down here, there's multiple networking components that you can actually install onto your cluster for initializing the networking. But the one here I'm going to use is Calico. Calico is a very popular networking solution for Kubernetes. So you can sort of see here, it says first we need to download the Calico configuration file on the master node. You can reboot, and I'm not going to reboot it right now. It should be fine. If you were to do this correctly, you would run through every single step. But then here, we're just going to apply the Calico. what happens. You can see, the Calico itself has created a lot of custom resource definition files, and they're just, where a company or a resource or, a unique person can take some of the actual existing components within Kubernetes and kind of expand them to do something different than that they were originally designed for. So, but right now we don't need to worry about that because Calico will create all of the necessary interactions between all of our pods. So again, if we kind of come back here, we say get pods again on namespaces. You can see that right now, you've got a new couple of containers. Couple of pods that have been initialized here. With certain containers being created, and these are going to take a few moments. So these are actually going to take a few moments to initialize. But when they actually come up, they will provide us the network inside of the Kubernetes. So if I kind of come down here and I sort of say get nodes, you can see now, okay, so you can see now that previously our control plane node had not ready, had a status of not ready. Now you can sort of see that the master actually is ready, okay? So that's a big thing now because it's now up to 7 minutes. The master is now ready. So this master 2 is actually ready to take traffic for Kubernetes. So what I could do here is just before I kind of do this, you can sort of see, congratulations, your Kubernetes cluster is now running. I kind of put a note down here to sort of say, but before I could start, I had to remove an existing taint. So I wanted to sort of see if there's any taints, and we will get into taints, but when you're upgrading or initializing anything in Kubernetes, one of the practices that is used is to actually put a taint onto your node. So that's one of the ways that taint can actually go into a node. So you can sort of see, this is in my new master 2 node. And if I was to create a pod right now, it wouldn't get deployed onto my master 2 because it actually has a taint to sort of say, this taint sort of says, no schedule, don't schedule anything here because basically, I'm actually upgrading it here, okay, or installing it in this case, but, to the same effect, really, that it's basically saying don't schedule anything right now. But really what I'm going to do here is just sort of say, remove that taint, okay. So kubectl taint node master 2, I'm going to say master, let me just do, the name is actually different here, so I'm going to say, probably going to have to say control plane, control plane. This is the actual command that I actually needed, so I'm going to update that here. I'm going to actually update that because it basically came as the name of control plane. So, but I found it from describing my taints on the Kubernetes system here. So it would be kind of easy enough to kind of find out this could be master, could be control plane. But for me, in this case, it just came as control plane. So let me say that everything here looks to be good so far. Now, this is a second. This is a kind of option that we can install, for load balance installation here. Right now, I'm not going to do this. I've done this in the past, and these steps work. I'm not going to do this right now in this video because it will just take a little bit too much time. But really, you could actually install. Let's see if we don't have any. You can, yeah. So you can install a load balancer here as well, which is good. I'm not sure how long this is actually going to take. Let's see if we can do this quite quickly. I'm conscious of the time. Okay, so it looks like it actually did work. But really, you could walk through those steps themselves, and you could basically verify that the actual deployment is now working. But I can sort of say, let's see if we can just create a quick. Let's see if we can just create quick deployment here. Okay. I have to get back here. Let's see. So you're all set. Okay. So at this point, we're going to create our deployment, because what we've done is we've used Metal LB as our load balancer on a Kubernetes deployment here. So I'm just going to take these here, put this here. Sorry, just going to quickly put that. Let's apply our Kubernetes. Deployment. Okay, so our deployment and our service has now been created, and we've just installed Metal LB. Again, there's various options here available in the Kubernetes world of what load balancer you really want to use, but you can see that we now have container creating, and then finally the container is actually running after 21 seconds. So the internal IP to the actual pod is this, and it's running on node master 2, which is our master of our Raspberry Pi. So if I was to try and say, let's see, get service here, you can see that the external IP is 200 here. Okay, so the cluster IP and the external IP to the load balancer here is 200. So what we can do here is we could check and see in the curl to see if we can curl that 200, and we do get a positive response here that basically says, we're just curling our load balancer front end page very simply at the moment, but we do get a welcome to Nginx. That basically proves that when we did this deployment back up here, we specified an image here of Nginx using the latest, and we specified a port. But it proves that the Nginx is actually working, and it proves that when we created our service, we basically sort of said, we want to use an external IP of 200 right now, just for quick local testing, just to make sure that our setup for Metal MB load balancer is actually correct, which is here. So you can sort of see here, it's the same IP from 200 to 254, but basically it means that your curl is working, your setup is working, and then you can finally go to your browser, and you can run that, and you can see welcome to Nginx, exactly what we saw when inside of the curl command. So the Nginx pod is up and running, the containers are all fine, the load balancer is set up,